Welcome to our Azure Incident Retrospective. I'm David Steele.
I'm Sami Kuba. We work in the Azure Communications team.
In addition to providing a written post-incident review after major outages, we also now host these retrospective conversations.
You're about to watch a recording of a live stream where we invited impacted customers through Azure Service Health to join our panel of experts in a live Q&A.
We had a conversation about reliability as a shared responsibility. So this includes our learnings at Microsoft, as well as guidance for customers and partners to be more resilient.
We hope you enjoy the conversation that follows.
So which incident are we going to be talking about?
Super. Today we're talking about an issue that took place on the 19th of April. It was just under 3 hours long. It's an incident that was MySQL and MariaDB with a primary service that affected in West US. However, there was unexpected impact to Databricks, which we're going to talk about as well.
And so to talk us through this incident, what happened and what we learned, I'd like to introduce our guest speakers for today. So first up, we have Roger Barja, Vice President for Azure Database for MySQL.
We also have Hadish Agrawal, a Senior Software Engineer for Azure Open Source Databases.
And finally, Lindsay Allen, our General Manager, VP of Engineering from Azure Databricks.
Super. Roger, can I start with you? Could you please walk us through what happened and let us know how were customers impacted during this?
Happy to do so. We will be walking you through the cause and the factors that contributed to this incident. And I'd like to begin by talking about the impact of this event, which is always important for us to understand. We have roughly 1,200 MySQL MariaDB single server instances in the West US region. And during this incident, roughly 770 of these database instances were impacted. These servers were actually running, but our customers could not actually connect to these database instances. So applications that were attempting to carry out operations against these databases, customers who are attempting to connect to them would time out or fail. And roughly 70 of these database instances were used by Databricks. And some of these database servers support control operations for Databricks. So as a result, their customers were also impacted. And not just in the West US region, but other regions as well. And I believe we're going to discuss the reason for this later in our presentation. But I want to first just pause for a moment and apologize to our customers who place their trust in us. Security and operation are our top priorities as a service team. And our aspirations are to deliver this to our customers and ensure high availability of our services. And in this instance, we did not live up to this. We fell short. And we understand that this not only impacted our customers, but Databricks customers as well. We deeply regret this, and we promise to take whatever we learned from this incident and apply this to future operations going forward. Now, let me explain how this incident actually happened. And to support this explanation, I'd like to bring up a diagram of our single server connectivity in our regions. So all connections to Azure Database for MySQL single server, Postgres single server, and MariaDB single server are established through a gateway. And this gateway is responsible for routing all incoming connections to the respective server that's sitting in our fleet. And this gateway server is hosted by a small group of stateless computer nodes behind an IP address. Well, as part of our Azure infrastructure modernization, we're moving all services to a new ARM-based gateway connectivity rings. And to date, we've migrated roughly 1/2 of our single server fleet to this new connectivity architecture. And on this particular day, we're migrating servers in West US, beginning with MySQL and MariaDB. There are 4 steps that happen during this migration to this new connectivity ring. The first step is we actually will go ahead and actually assign all the compute nodes to this new ring. And we'll call this new ring CR16. That's the name of the new ring that was being built for this region. And the operator that's doing this will manually test the ring by standing up some test database servers that will connect to this ring to actually verify that it's up and running. And they'll actually leave these servers connected to this, and I'll explain why a little bit later. Then they'll set this new control ring as the default connectivity ring for all new server connections. And that step was completed, so any new server connections that were coming in were flowing through this new connectivity ring. And then finally, the operator will go over and start a script that will migrate all existing database servers to stand up behind this new connectivity ring that's been built, tested, and we know it's running. This backfiller migration is carried out by a script. And the way this script works, or I should say it worked at the time, we are making changes, was it will actually do a lookup for new connectivity rings in that region that have a DNS mapping for a database server that's attached to it. That's why we leave the test servers actually up and running. And so these rings that are in this database with a database instance attached to it are considered targets for this migration script. Well, what the engineer carrying out this operation did not realize is that previously another engineer had built a new connectivity ring in that region. The ring was not configured to handle MySQL or MariaDB database connections. It was actually being set up for another database service. And that setup actually wasn't complete, but they had assigned a MySQL database server to that ring. So because a DNS mapping had been made from a MySQL database server to a new control ring, CR11, that wasn't actually completely configured for MySQL and wasn't even up and running yet, it was considered as a valid target for that migration script, in addition to the valid tested ring CR16. At 426, the migration process started with both CR11 and CR16 as migration targets. A subset of the servers in that region then landed behind that ring that was not set up for MySQL, not properly configured, and as a result, they lost connectivity at that point in time. Other servers were migrated behind the correctly configured and tested ring. Those servers had no connectivity issues whatsoever, which is why we had a subset of the fleet in that region that was impacted by this event. I'll go ahead and stop there. Hopefully that explains what happened.
That's great. Thank you for running us through kind of what impacted customers there and what it felt like for both MySQL and for Databricks here. A question for you, Harish. I know we mentioned in the post-incident review that we're kind of adding or as we're needing to add or update these IP addresses, that we have to notify customers of this, and some customers might need to add that to expand their rules. Could you talk us through that a little bit?
Yeah, so as part of this migration, as Roger just mentioned, we add new compute nodes and it builds a new connectivity ring altogether, which has a new public IP address. So from customer point of view, when the client attempts to make this outbound connection, they are currently connecting to, say, CR1, which is the current pass v1 connectivity ring. They need to allow this new IP address in their outbound firewall rules, so that the client can actually make connection to the target connectivity ring. Now, if any customer have relaxed outbound rules where they have like a broader subnet or allow all, they may not have any action to take, but any customer who have selective outbound rules configured, they will have an action to take, where we have published, I think starting Feb or Jan of this year, we started sending notification out to customers providing all the subnet at region level, where if a customer has presence in a specific region, what should be the subnet that need to allow in their outbound rules.
Super, thank you, Harish, and it underscores the importance of Azure Service Health and customers making sure they consume notifications and take actions when they need to. So it's very important, otherwise their outbound traffic might be blocked. I was hoping you could just walk us through, could you please tell us, Harish, how we responded? And I'm really interested particularly in the detection, like how long it took to detect and how we detected this, and then what steps we take to mitigate.
Yeah, so once the migration started, close to like 15 minutes later, there was an incident reported by Databricks as connectivity issue from multiple regions. As it is multiple region, SEV1 bridge was initiated and MySQL team was paged out. All necessary stakeholders got engaged on the bridge, and they started looking into it with respect to a multi-outage region. And the issue which was originally reported was that connectivity has failed and customers not able to connect across different US regions. And the team started looking into regions at a time, and we didn't see any issues in West US 2 or South Central US or East US 2. However, from West US 1, we didn't see any issue as yet. So there was no problem reported from West US based on the telemetry that was being monitored as part of this migration activity. I'll come to that on as well. So we started engaging with Databricks, collecting all the servers that have problem connectivity. And upon looking at the tracers, we didn't find any login requests coming in. So that basically started giving us some indication on something is not right with the connectivity path. Like it's not the data plane per se where the server itself is down, but there is something broken along the network connectivity area. And upon looking at multiple servers, we identified that the login requests are not coming in altogether. And when a customer does NS lookup, they will be able to see the CR11 and CR16 Roger was referring to. And we identified which connectivity ring seems to have a problem where login requests are not working. So with that, we were able to identify that the login request to CR11 seems to have problems. And a dedicated team was actually paged out, which built the CR11 team, and engineers on call started looking into that and identified that CR11 was not properly configured. And that explains why the connectivity was not working. And it also explains why a failed login telemetry was not emitted, because this ring didn't have the app which is responsible for identifying the login request and generating a failed login attempts with distinct error codes, whatever it might be, right? So we did not see any failed login attempts, but there were no past login attempts as well. So this is one of the repair items I'll talk about. But this is how we identified that the problem was with a connectivity ring which was not properly built, but customers were migrated. Part of the customers were migrated as part of the recently completed migration activity in that region.
Got it. That's helpful to understand, and I like the point that, for the same reason that the servers themselves weren't ready to handle customer databases, they also didn't have the right monitoring in place, and that kind of hampered some of our detection and therefore some of our customer communication. So Harish, is there any other kind of learnings or repair items from the underlying fabric before we turn to some other teams' repairs?
Yes, I think there were a few opportunities we found when we started retrospecting the issue. How do we avoid it to begin with? That's the first and foremost priority, where we should not be into this situation what we got ourselves into. And the second thing is, how can we detect it sooner rather than later? Like, even if we save 5 minutes time, that's a 5 minutes outage we protect. So we ended up with a few repair items. One of the repair item was to ensure that when a ring selection, the target ring selection is being done, in addition to just validating if a test instances exist on this connectivity ring, we will also validate few other areas where what's the status of the app, what's the last login attempt on that ring. If we do not have any login attempt, a successful login attempt, even if that ring is healthy, that will not be used for migration, because at that point in time, an engineer needs to go do a validation, make sure everything is looking good. And that's one of the repair item where we will ensure that either incorrectly configured ring or a ring without a successful login attempt is not picked up for the migration. So that should avoid this issue to begin with. And the monitoring point of view, I think what we missed was everyone was focused on the failed login telemetry rather than in general success login telemetry as well, because a dip in successful login telemetry should also indicate something is not right. So we started breaking down the telemetry to a granularity of ring level, app level, and success and failed, all different telemetry that we have. So this should give us a clear indication on if the login attempts themselves have gone down.
Got it. That's great to understand. Yeah, no, 0 successful calls sounds like failures. Roger, I wanted to swing it back to you and talk about any kind of learnings or repairs from the MySQL side. Could you talk us through that?
Absolutely. I mean, first off, the fact that we had to be notified by a customer that there was an event going on was unacceptable. We have to, there's an initiative across all of Azure services to automatically detect failures that are happening within seconds. So this was clearly a miss on our part that we did not detect this. We were relying upon error messages coming from the gateway. And as Harish just explained, the gateway wasn't configured, did not have the agent that was sending error messages. We should have detected a drop in activity in that region to our service. I mean, that was a 70% drop of database action activity in that region. So we will be adding an alert that will be independent of getting error messages or logs from the connectivity to look at drops in activity within a region. We have taken a repair item against that. And again, this is an event that we don't do, this kind of migration we don't do, but we've also talked internally that we need to coordinate. These are big changes that are taking place, letting operators know we're making a change in that region. If something goes wrong, here's my number, call me, contact me immediately. So we do need to coordinate a little bit more when we're making major region changes like this.
So, Roger, I have another follow-up question. You mentioned that we don't create these changes very often, like this is done very, very periodically as we add hardware. Is this one of the reasons that, I mean, I know that human error played a role in this. Was it because we don't want to invest in automation for something that happens so infrequently? Is it a trade-off between automating something that happens once every X years, doesn't quite pay dividends because the situation changes from time to time?
That is a fair question. We've actually stacked rank all of the availability issues that we have seen over the years, and we're working through that list. That's how we're automating and doing the automatic detection and even automatic mitigation. And we haven't done a rotation like this in 4 years, so we've never seen an event like this, so it would have been pretty low on the list. But again, we just have to be paranoid whenever we think, again, very simple connectivity drop alarm, which can detect a number of issues potentially in the region. Connectivity powers everything. So again, this is a repair that I think will cover a lot of events.
Magic. Thank you very much. Lindsay, it's time if you can take the mic for us. And could you tell us a little bit about Databricks? I mean, I know that there was impact. There was also impact beyond West US. Could you walk us through this, please?
Yeah, thanks. Yeah, it's as you heard, right? Across Azure, we're investing lots of engineering effort on smarter detection, early warning system, right? Not just actually alert on what's happening, rather get alert on something abnormal, something not happening, which is the signal. So same thing, especially for critical infrastructure item. So Databricks have a critical dependency on MySQL servers. And if I take half step back, right, for those of you using Azure Databricks, you know you have operations to create these Spark clusters, compute clusters. Could be general purpose cluster, could be job cluster, could be submitting that through APIs. I know many of you just doing that through automation as well, right? In this case, you'll get impacted. Some of you get impacted, either get timed out, UI problem, or your job never finished. So then you find out later, right? It didn't happen. And so the heart of this whole operation is a component called control plane. And in order for your cluster to spin up, your job cluster or general purpose cluster, or delete it, for a matter of fact, is coming from a key component. Think about the heartbeat, is called control plane. And this control plane component of Databricks have critical dependency on MySQL server. And because of legacy reasons, when Databricks first launched on Azure in 2017, and we have limited number of these control planes across the world, right? As we progress in the past 7 years, so we started to have more and more of these control planes. But in this case, it happens they still have cross-region dependencies. So we have control plane US West 2, but US West 1, and I think we did migration from 1 to 2, and the South Central US still have dependencies on US West 2 control plane. So we continue to working with Databricks engineering to mitigate these cross-region dependencies and to avoid like multi-region outage impact to customers like yourself. And in any case, we try to automate these as much as possible. And we actually would like to, if it's applicable, work with you, right, to migrate your dependencies of your legacy workspace to the local control planes.
Got it. Thank you for running us through that, Lindsay. But before we touch more on the kind of multi-region impact, I wanted to ask about one of the repair items from the post-incident review. We talked about adding alerts, just as Roger was talking about kind of improved alerts and detection from a MySQL perspective. Is there a Databricks improvement here in terms of alerting to multiple databases becoming unavailable, or we feel pretty good about how quickly Databricks kind of noticed the impact here?
Yeah, we actually had this conversation in one of our monthly senior executive fundamentals review, right? Because generally, I think MySQL be considered a user-facing service. And for this case, I think we would like to see there's an infrastructure level alert, early warning system, and the Databricks is going to subscribe to it. So if we see any, like we have the system called Brain, right? Brain have these service level indicators alert. If MySQL add to it, we'll subscribe to it. If we see any signal, we will take action. So that's essentially what we're working on, together with Roger and Harish's team.
Super. And Lindsay, I mean, you touched on it earlier that today the control plane there's multi-region dependency because of the control plane. Are there plans to create these so they're independent, so that you have a single control plane in a single region, and if the region is impacted, it won't spread beyond that?
So there's a lot of that going on, and also we actually want to be smarter about that, because in many cases, right, the remote itself is not a necessarily problem. It's like multi-AZ challenges, right? Sometimes they said, okay, I'm in this region, and my application could be control plane, could be data plane, could be just your app, can deploy to different AZs. And in the past, I'm pretty sure you did this live streaming similar issues, especially USCs too. So sometimes these AZs are not balanced. So just because I can deploy to different AZ doesn't mean I'm resilient across AZ, right? Because if your largest AZ goes offline and everybody go to a smaller AZ, then we all go offline, right? So we want to do better than just a simply check box. We want to actually be smart about cross-region dependencies. That's what we're working on, yeah.
Great. Thank you, Lindsay. And for folks who aren't familiar, AZ is an Azure Availability Zone, which is within a region, completely independent power, networking, and cooling, kind of dividing data centers up into their AZ. So thank you for explaining us through that. One last question here. I always use this opportunity to turn my attention to my co-host. Sammy runs the Azure Communications team. Sammy, how did we do? Did we keep customers up to date? Were we able to send communications? You know, how did we do?
There are a couple of things here. First of all, one of the challenges we have is that we have Databricks on Azure. When we have this, we kind of support this. And then Azure Databricks have their own status page as well. And so for customers, independent of this, there's sometimes two versions of where they're looking. Now, typically speaking, they'll publish to a public status page, whereas we won't, because we have the ability to target customers and communicate with them directly. We can highlight impacted resources at a time instead of just going broad. And so if 20% of customers are impacted for Azure Databricks, you might see that they'll put it on their public status page where we'd send targeted comms. In this situation, as they alluded to, as Roger and Lindsay and everyone alluded to earlier, Azure Databricks were the first customer to understand that they were impacted. And so we went to the status page because this was multiple regions, and we toasted or we sent portal communications to Azure Databricks customers behind the north wall. So they would have received it in their portal, they would have seen it on the status page. It was only a little bit later when we realized that the issue was impacting MySQL and MariaDB as well that we put out on the status page. Learning, as we've been teasing apart and learning about this more and more, I put a question mark around, should this have been on the status page? I mean, we were communicating to impacting customers. We know that while the impact to Azure Databricks did impact multiple regions, this wouldn't have impacted every Azure Databricks customers in those regions as well. And so we look at the blast radius or the impact, it was potentially a lot smaller than we're typically used to when we go to the Azure status page. But the other piece, our time to notify because of the lack in detection was longer than we would have liked it at all. Typically speaking, we know that humans are very slow. By the time we look at things, we understand impact, we understand which subscriptions are impacted. That can take minutes, sometimes hours to ascertain. And typically speaking, we look at Brain. Is Brain the right scenario for this? And we assess whether we want to onboard to our Brain, which is our automatic notification system. It typically notifies customers within around 15 minutes. And I think we still need to assess, is this scenario worthwhile of onboarding to Brain? Of course, we need to prioritize which ones go on. But so overall in comms, I think for a lot of customers, it would have been confusing. We need to get crisper when it comes to our, we need to communicate it clearer to customers to understand when they go to the Azure Databricks status page versus the targeted communication. And I think we need to get firmer on when we go to the status page and be a little bit more diligent there.
Thank you for watching this Azure Incident Retrospective.
At the scale of which our cloud operates at, incidents are inevitable.
Just as Microsoft is always learning and improving, we hope our customers and partners can learn from these too and provide a lot of reliability guidance through the Azure well-architected framework.
To ensure that you get posted incident reviews after an outage and invites to join these live stream Q&A sessions, please ensure that you have Azure Service Health Alerts set up.
We really focused on being as transparent as possible and showing up and being accountable after these major incidents.
Whether it's an outage, a security, or a privacy event, Microsoft is investing heavily in these events to ensure that we earn, maintain, and at times rebuild your trust. Thanks for joining us. Thanks.